For our final three examples, you'll see some examples of when you're going to get extraneous solutions. And so this is a great, these are great examples to practice solving quadratic equations in addition to solving these logarithmic equations. And so notice that we, again, just like all the other examples, we have logs in every term. And so we're going to take our left side, we're going to rewrite our left side as one log. So log base 3 of, again, the sum of logs is the log of the product. So we're going to rewrite the left side as the log of one thing. And that one thing is the x times x plus 1. And on the right side, we don't change that because we already have one log. So we have log base 3, and therefore the arguments have to be the same. So if the arguments have to be the same, we get x times x plus 1 is equal to 6. What you should recognize at this point is that you have a quadratic equation. So when we have a quadratic equation, normally we're going to go ahead and rewrite the equation in standard form. So x times x is x squared, x times 1 is x, equals 6. Gathering all the terms to one side is rewriting the equation in standard form. So subtracting 6 from both sides, we get x squared plus x minus 6 is equal to 0. And then you might remember that we have two different methods with which to solve a quadratic equation in standard form. One method is factoring. So factor the left-hand side, we get x plus 3, x minus 2 equals 0. So if you need to practice your factoring and solving quadratics, this would be a good time to do that. Setting each factor equal to 0, we get x plus 3 equals 0, and we get x minus 2 equals 0. We get x equals negative 3, and we get x equals positive 2. So then again, now like I said, we're gonna see, all right, can we replace x in the original equation with negative 3? Does negative 3 work? And you should be saying to yourself, no, negative 3 doesn't work because that x right there must be a positive number. And so you're not even allowed to put negative 3 into there either, because when you add 1 to negative 3, that would become negative 3 plus 1. That would be also a negative number. So, sorry, I kind of messed up there. When you replace x with negative 3, you get a negative number. So that's bad. So you can't take the log of a negative number. And so therefore, x equals negative 3 is an extraneous solution. It's an extra one. We're not going to put a box around it. We're going to cross it off. It doesn't belong. It solves the quadratic equation, but it doesn't solve the logarithmic equation. Therefore, it doesn't belong. X equals 2, on the other hand, 2, you can take the log of 2, and you can take the log of 2 plus 1. So check, x equals 2 is a valid solution, and it's the only solution. So we might want to write the word extraneous, but I think that you don't need to do that. You just need to make sure you cross it off. So x equals 2 is the only solution, and that is the solution of the original equation. All right, let's see if I can get one more example in before the 5-minute mark. So example number 2, we have the log of x plus 3 plus the log of x minus 2 is equal to the log of 4x plus 4. And just like all the other problems, we want to combine the logs on the left side. So we're going to combine the logs by using the properties, the multiplication or the product rule. The sum of the logs is the log of the product. So that gets the left side as one log. The right side was already one log. And therefore, the arguments have to be the same. So x plus 3 times x minus 2 has to equal the other argument, 4x plus 4. And then we're going to multiply these two binomials together using the FOIL method. X squared minus 2x plus 3x is a plus 1x. And then we have a minus 6 equals 4x plus 4. And then we're going to subtract 4x from both sides. We're also going to subtract... Oh, I messed up. Oh, what a bummer. This is not going to work out. I thought I had it. I don't know what I did wrong. X squared x squared minus 3x minus 10. That was not supposed to work out that way. Oh, yeah, it did work out. I don't know what I was just thinking. Because this factors x minus 5 times x plus 2 equals 0. So for this first factor, x minus 5 equaling 0, x has to equal 5. Over here, x has to equal negative 2. And when we put a negative 2 in place of x, let's do this. When we put a negative 2 in place of x, negative 2 minus 2, that's going to be a negative number. So that's no good. That's an extraneous solution. 5, on the other hand, we could put a 5 in there, there, and there. So therefore, 5 is the winner. 5 is the solution. And let's have you do the third example, and we'll do the thing that we did last problem, or in the main course problems. I'm going to give you the problem. I'm going to pause the video. I'm going to try to remember to hit resume next time when I'm ready to show you the solution, and have you give this a try. Log base 7 of 2x plus 16. So go ahead and pause the video. Try this one. I'm going to work it out, and then I'm going to resume recording and then show you the solution. Okay, I did it right this time. As you can see, x equals 4 is the only valid solution to the original equation. You should have gotten negative 5 and 4, and then determined that you can't put a negative 5 in place of the x, because that would, when you add 4 to negative 5, you'd get a negative number. And over here, you put a negative 5 in there also, you get a negative number. Negative number, and then negative 5 here. Even though you could put negative 5 in place of this x, because 2 times negative 5 is negative 10, plus 16 is 6. That's a positive number. All the negative 5 has to do is make one of these arguments less than 0, so that's when we would cross it out, and we just get x is equal to 4. Hope that all makes sense. Let me know if you have any questions.